So the NTSB identified the failure of the propeller blade to be the root cause of the accident. The propeller blade was made by the composite blade manufacturer Hamilton Standard. The actual fail blade was the Hamilton Standard 14RF serial number 861398. 17 months prior to the accident, Hamilton Standard had two identical failures of the same blade type due to metal fatigue. In those two cases, the aircraft were able to land safely. The Hamilton Standard 14RF is comprised of three main components: the blade airfoil, the blade spar, and the taper bore. The blade airfoil is a composite buildup of fiberglass, epoxy, foam, and nickel. This combination of materials ensure a lightweight design for maximum efficiency. The blade spar is a forged aluminum alloy that is the main load-bearing element of the blade. The spar is connected to the propeller hub in which it rotates on and is encased in a composite airfoil. Inside the blade spar is what is known as the taper bore. A taper bore is a conical hole that is used for weight and balancing of a blade. Manufacturers would use leaded wool for balancing and seal it in the taper bore by either using cork or sealant. An earlier practice of Hamilton Standard was to shot peen the taper bore. This would be a way of strengthening the metal of the bore by compressing the surface of the alloys. Think of it as surface-based microforging. The blade that failed on the aircraft was not shot peen, but that was approved by the FAA. "17 months earlier, the failed blade was found to be suspect during a manufacturer-wide grounding of all aircraft with that type of blade installed. During that blade inspection, a mechanic found cracks in the taper bore through the use of NDT inspections. But the mechanic simply thought that the cracks were due to tooling marks from extracting the leaded wool from the taper bore. Hamilton Standard's SOP at the time simply stated that the mechanic sand over the cracks. This is found to be a mistake now because that meant the mechanic left cracks below the surface of the taper bore. Upon further investigation, the NTSB also found chlorine along the walls of the taper bore. Chlorine is highly corrosive to aluminum and is catalyzed by high temperatures. The chlorine is thought to be found from the bleach that is found in the cork that is used to secure the leaded wool in the taper bore. In combination, the cracks in the taper bore along with the chlorine led to the failure of the propeller blade.